Okay, question 3, here we go. And the shout out this time is going to Akirita. There we go. Okay, looking at this question here, we've got a situation with some spinners. The first question is asking what happens if spinner A, if we spin that around, what's the probability of getting a 2 or a 6? So when we look at spinner A, we've got 2 and 6 here, so that's 2 possibilities out of a total of 4. And so 2 over 4 is a half all up, and that's it. Question B, Marino plans to offer a game where the player can win $10. The player will spin each spinner only once. If the total from the 2 spinners is more than 10, then the player will win $10. He plans to charge $2 to play the game. To test, Marino plays and draws the following graph of his results. Okay, from Marino's results, and that's the key word there, from his results, that means that we're looking at this graph and we're not looking at theoretical probability up here. So just be aware that we're looking at the graph only. So from his graph, what's the probability that a player will spin a total of more than 10? Okay, so these ones are more than 10, and that one there is 5, and that one there is 4, so that's 9, and we're told that he's done it, well, has he told us how many times? So that's 9 out of a total of, so if we quickly count these up, there's 50 there all up, so out of 50, so that's by counting, like we've got 18 there, we've got 11 there, 2, 10, 5, 4, adding all those up we get 50, and that's how I got the 50. Okay, should Marino trust the results from his experiment, give results for Y? So I would be inclined to say no, simply because of sample size again. 50 is good for making some kind of call, but if we want to be definitive, we need a bigger sample size. So no, sample size is too small. And what we're implying there is that if he repeated the experiment, he would get different results. So if experiment was repeated, he could get different results. In fact, we won't say could, he probably would. Get different results. Okay, what else? What he's done here to get this is called experimental probability. So you'd really want to compare that to theoretical probability as well. So we'll just say needs to consider. He needs to consider theoretical probability. As well. Okay, so on to the next question. Will Marino make a profit after 100 games? Use theoretical probability to support your answer. So what we're going to think about is all the possible totals that he can get from spinning these. So let's come up here for a second. So he could, let's just write up a little table in the corner here. So he could get 2, 4, 6 or 8 from the first one, and he could get 1, 3, 5 from the next one. So if we add these up, that'll give us 3, 5, 7, 9, 5, 7, 9, 11, 7, 9, 11, and 13. So if we're looking at the probability of getting each, it can come from this table. So let's just go back to the question so that we know what we're answering here. So will he make a profit after 100 games? So what I'm going to do is write out all our possible totals from that graph that we made up there. In fact, I might even just bring that down for us. So we'll put that there. Perhaps we'll use Snippy instead. Let's grab that. There we go. That's better. Okay, we'll bring that down here, so we've got it to work with. There we go, paste. There we go. Now, why is it way up there? Come up here. Okay, that's a bad idea. Let me just write it out again. 2, 4, 6, 8, 1, 3, 5. Okay. So we've got 3, 5, 7, 9, 5, 7, 9, 11, and 7, 9, 11, 13. Alright, so our totals go from 3, our next one is 5, then we've got 7, then we've got 9, then we've got 11, then we've got 13. Alright, the number of 3's that we have is 1 out of a total of 12. Number of 5's we have is 2 out of 12. Number of 7's that we have is 9 out of 12. Sorry, that's 3 out of 12. Number of 9's we have is 3 out of 12. Number of 11's we have is 2 out of 12. And the number of 13's is 1 out of 12. So those are our probabilities. Okay, so what we can do here is work out what we call our expected value. So we'll just want to look at all of his rules up here again. So he charges players $2 to play, and if they get more than $10, they win. Okay, so what we'll do here. Okay, what we'll do here is we'll make up another table. We will look at his profit from each roll. So almost exactly the same, except we'll look at the profit for each of these individual rolls. So he only loses money if it's more than 10. And so he's going to have minus 10 here and minus 10 here. And all the rest he's making a profit of 2. Now the probabilities haven't changed there, so I've got 1 over 12, 2 over 12, 3 over 12, 3 over 12, 2 over 12, and 1 over 12. Okay, now if I multiply those all out, I'll get an expected value. So we're going to say that expected value here is 2 times the probability of making $2 profit, plus 2 times the probability of the next $2 profit, which is 2 out of 12, and then plus 2 times 3 out of 12, plus 2 times 3 out of 12, plus negative 10 times 2 out of 12, plus negative 10 times 1 out of 12. Alright, so we want to put that into a calculator and work out what that comes to. But before we go any further, I've just spotted a little mistake here. What we want to do here and here is actually make that 8, because although he loses $10, they've already paid him 2, so we need to change those ones to negative 8 and negative 8. So we need to change that down here as well. So that's negative 8 and negative 8. Okay, and putting that into our calculator, that gives us negative a half. So in other words, on average, he's going to lose $1 every time he plays this game. So our expected value over 100 games, so over 100 games, over 100 games, that's just wonderful, isn't it? Let's try that again. Over 100 games is 100 times negative a half, which equals negative 50. So in other words, over 100 games here, he's going to lose $50. So will Mario make profit after 100 games? Let's answer that with a sentence. No, Marino will lose $50 over 100 games. And that is the end of this paper.